All right, so a couple people asked me if I can make a video to help with the review. So I'm going to go through and do some of the problems that were on your review guide. So this way you know exactly what it is I'm looking for and how you should answer each question. So the first one that so this video is going to be quite long, but you can skip through until you see a question that maybe you weren't sure about. So this one, true or false? The square root of 4,000 is an element of Q. Now, ones that we were doing in class were ones like this, and on your test there'll be one like this as well, where it's a little bit easier. Remember, there's no calculator allowed on your test. So it might say true or false, 4 is an element of a rational number. Now, when you first look at this, you might think that it's not an element of a rational number because you see the radical. But remember, anytime that you can reduce your radical, you must do that. So the square root of 4 is actually equal to 2. So this square root of 4 is really asking, is 2 an element of our rational numbers? And since we know that 2 is an element of a rational number, this would be true. All right, so that's how it may appear in your test. If it's on your test, it will be one that you can actually do. It's a little bit easier. So let's do the problem that was here, the square root of 4,000. So if you plug that into your calculator, this is actually equal to 20 times the square root of 10. So here, and we'll learn how to do this later on as well. But for right now, this is what the answer is. And since it doesn't eliminate or get rid of the radical like it did here when we took the square root of 4, this is an irrational number. So it's not a rational number. So this would be false. So for the actual problem that was here, it will be false. All right, let's say negative 20. And I ask you, negative 20 is an element of natural numbers, true or false? If you look at this one, natural numbers are 0, 1, 2, ... So it's our counting numbers. And since this is negative, it is not an element. So that one will be false as well. Let's say 50 is an element of our integers. Since our integers are both positive and negative whole numbers, this one would be true. All right, so those are some examples that you might see on your test. For this problem here, I worked out the solution for you over there. So this one is actually false. All right, I'm going to go through these problems pretty quickly though, because there's a decent amount that I want to go through. I'm trying to not make this video too long. All right, so for this one, it says there are 25 elements in a universal set. If the number of elements in set A is 14, and the number of elements in set B is 15, and the number of elements in A intersection B is 6, what are the number of elements in A union B? So in A or B. So first thing, if you want to solve for this, is we should draw our Venn diagram. So whenever you're answering these on your test, you'll be provided with your Venn diagrams, and you must complete them. So there's our two sets. Let's just say A and B, and this is our universal set. So the first thing we'll fill in, remember, is we always fill in the innermost parts. So this is A intersection B, so it's where they overlap. So 6 is here. Now, in this entire circle A, we know that there are 14 elements based on what they tell us. Well, we've already accounted for 6 in this intersection part. So to find out the remaining part that's in this part of our circle A, we would then need to say, well, there's 14 total elements. We've already figured out 6 of them go in the middle. So 14 minus 6, that is equal to 8. So that means there are 8 elements here that are just in set A. And then for set B, we have 15, but that 15 is including everything that is in this entire set, so this entire circle. And the same thing, let me just draw this again, see if I can match up the circle that we actually have. So same thing as before, we're already accounting for 6 of them here. So now we need to figure out, well, how many elements are just in circle B, or just in set B, just in set B. So we will then say, well, there's 15 total elements in B. Sorry, let me not use a marker, but let me use a pen. So there's 15 elements in set B, and we already know that 6 of them are accounted for. So 15 minus 6 is 9. So this 9 has to go in here. So let me just redraw this Venn diagram so it's a little bit clearer. So there's our two sets, and we solved for 8 is here, 6 is here, and 9 is here. So if we want to figure out how many are in A or B, or A union B, we would just add them up. So 8 plus 6 plus 9, that will then give me 8 plus 6 is 14, plus 9 is 23. All right, if you try to just add these 3 together to begin with, 14 plus 15 plus 6, well, 14 plus 15 is 29, plus 6 is 35. That's more than what we have in our elements to begin with, and that's because you're accounting for everything that was these sixes appear twice. So you're double counting them. So you would need to, you can't just add them all together. All right, so on your test, I want to make sure that you guys know to draw this Venn diagram, and this will help you to solve. All right, so for here, it's saying describe in words the shaded region of. So here's the two parts. So we need to say this in words. So you can say this a few different ways, but one of the easiest ways of saying this is, well, this is set X. The only thing that's not colored in is set X. Everything else is colored in. So we can say, so describe everything or all elements not in set X. Right? I would be okay and fine with that as an explanation. For these two, here, the only thing this means this part is where they both share. So this part here that's not colored in is where X and Y overlap, or elements that are in both X and Y. And then out here that's not colored in are elements that are not in X and Y. So the only part that's shaded in is the part that is just in set X, so it's only set X, or this part here that's only set Y. So in words, we can say all elements that are in only set X or only set Y, and that would be a good enough answer. All right, let's just go through real quick. If I draw this Venn diagram, let me go through in words. Let me just go down here. If I just draw this Venn diagram, what each part represents. So here we have A, here we have B. So here, this is anything that's only in A. This is anything that's only in B. This is anything that's both. And this anything out here is not in A or B. So that's this region. So whenever you're filling these parts, it's important to understand what the regions are. All right, this one, it says, in a circle of music lovers, 14 people play the piano or violin, 8 are piano players, 5 play both. Find the number of violin players. So it doesn't say find the number of just violin players, it's find the number of violin total. So when you're solving these, you will need to show me all your work on a Venn diagram. So here we have set A, here we have set B. All right, so let's start filling. Remember, we always fill in the innermost part. So it says 5 people play both instruments. So this is where we have people that play both. So that's 5. It tells us, so I'm sorry, let's not do A and B. Let me change this because we have different things here. So let's change this to say piano and violin, so P and V. All right, so then from here we have 14 people who play the piano or the violin, and 8 people play the piano. So that means 8 people play the piano in general. So this circle here tells us everyone that plays the piano. All right, we already have 5 accounted for because 5 played both instruments. So in this blue, you can only have 8 people total. Well, if we already have 5 accounted for, that means that the remaining people who play piano are 8 minus 5 or 3. And those 3 people only play the piano. Right now, it says 14 people play the piano or the violin. So that means those 14 people, let me get a marker. Let's do a different color here. Those 14 people play the piano or the violin. So those 14 people are either of those 2 circles. So let's go through here. We have 3 people that play just the piano, 5 people that play the piano and the violin. So there's 8 people that we've accounted for. Well, there's 14 people that play the piano or the violin. So if we subtract those 8 people that are playing the piano, then we know the remaining 6 must only play the violin. So that 6 must go there. All right. Then the question, though, for the final answer, it says find the number of violin players. So we only want the violin, but we want the violin in total, not just people who only play violin. So that's this entire circle. So there's 5 people who play the piano and the violin, 6 who only play the violin. So our final answer is 5 plus 6, and that's equal to 11. All right, the next ones, these aren't really necessarily going in any order. I just kind of took screenshots of all the photos, and so this one's kind of one of the first ones. But is -2 an element of Z positive? -2 is a negative number, so it's not an integer that's positive, so that won't be false. All right, that would have to be positive numbers, only positive whole numbers. And it says 1 over the square root of 7 is it an element of rational? Well, rational has to be a fraction, and I'm sorry, the fraction is P over Q, where P is an integer and Q is also an integer. Well, here 1 is an integer, so that works, but the square root of 7 is not an element of the integer set. So since the square root of 7 is not an integer, this is not a rational number. So this one would be false as well, right? It would have to be 1 over 7 would be rational, but since it's the square root, sorry about that, since it's the square root of 7, that is actually an irrational number. Right, so on separate diagrams like the one shown, shade the region representing. So we're going to then have to draw 3 different Venn diagrams, and they must be just like the one that we just saw that they have off to the right. So it's A, B, and our universe, and we need to draw 3 of these. All right, so now if we want to shade in these regions, I'm going to use this highlighter here. This says not B. Well, first let's mark out the area that is B. So this circle that I'm that I'm drawing here now is our set B. So not B is anything that's not inside that blue circle. So everything that's on the outside of here, everything that's in this part of set A, everything that's in this universe out here, all of this here is not part of set B. So our answer for this one would be this here. All right, for B, it says it's in A and in B. So this you would see written that on your test as A intersection B. All right, so the part that is in A and in B is this part here that they overlap. So this part would be our solution, and that's the region that's in both set A and in set B. All right, now for this last one, we're going to go ahead and fill in this part first, and that's going to help us with our answer because this is saying A union B, but we want the complement. So we want everything that's not in A union B. So actually, I'm going to fill in this circle first. So A union B is anything that is in either circle B or circle A. So this is actually the entire 2 circles colored in. So this is A union B. All right, now anything for the complement, anything that's not in this but still inside the universe is everything outside of these 2 circles. So that will be everything out here. So then just to give you the final answer for this C, the answer for this one would be everything that's on the outside of these 2 circles. So it'll be everything I'm coloring in here. Right, this is A union B complement. All right, there are a few questions that you 100% will need to be able to do for this type.